Okay, let's take a look at 42. Similar to 39, it involves a radical. This one's a little bit more complicated. That radical is in the denominator of a fraction. So I have no idea how bad this is going to be. Could be rough. So here we go, everybody. We are going to take here f prime of x by finding the limit as h approaches 0 of, and here we go, f of x plus h. So we replace the x with an x plus h. That's going to be a 1 over, we're going to have the square root of, and if that x got replaced by the quantity x plus h, I'd probably distribute the 2 in there and get a 2x plus 2h, and then a plus 1 at the end of all that. Ugh, that's fun. And then minus f of x, the original function, 1 over the square root of 2x plus 1, and all over h. Okay, that doesn't look super pleasant, but we'll see what we can do with that. I think my game plan here is to go ahead now and to try to combine those two terms into in the numerator into one fraction. So to do that, I just multiply by the opposite denominator. So this denominator is going to get multiplied over here. This denominator is going to get multiplied over here. I've seen that described as the flying x strategy before. So what's happening? This guy gets a root 2x plus 1, and then so does the denominator, 2x plus 1. This one gets a square root of 2x plus 2h plus 1 on both the top and the bottom. Okay, so what's that going to do for us? Well, I don't know if we're in great shape, but let's see what we got. Equals a limit as h approaches 0 of, and like I often do, I'm not going to play around with the complex fraction. I'm going to go ahead and get this down to just one numerator, one denominator. So let's start right up here. The numerator of the numerator ends up in my numerator. So this is the square root of 2x plus 1 minus the more complicated expression, the square root of 2x plus 2h plus 1. So that was the numerator of my numerator. Now, the denominator of my numerator, which is right here, is going to end up in the denominator of the fraction. And I'll leave that factored here as the square root of 2x plus 1 multiplied by the square root of 2x plus 2h plus 1. Okay, that takes care of that. And then the h here goes in the denominator as well. Actually, I should say that stays in the denominator. That's where it was all along. Okay, now this is a mess, everybody. Plug and chug, of course, is going to create a problem in trying to put the 0 right there for the h. So my hope would be that we can do something here to make the h in the denominator cancel out, and I think I see how we're going to do that. Similar to what we did, in the previous problem, 39, I'm going to multiply top and bottom by the conjugate of my numerator. So there's a binomial. We're going to multiply that now by the square root of 2x plus 1. And instead of a minus, that'll now be plus the square root of 2x plus 2h plus 1. And the same thing in the denominator, square root of 2x plus 1 plus the square root of 2x plus 2h plus 1. Got it, got it, got it. Okay, so what's that going to do for us? Well, up in the numerator, we are foiling a binomial times its conjugate. So the first product, this times this, just gets us 2x plus 1. The outer and the inners will cancel, and then the last product, here times here, is going to be minus the quantity 2x plus 2h plus 1. Now the denominator, oh my goodness, is a fright. All right, we have got the square root of 2x plus 1 times the square root of 2x plus 2h plus 1 times an h times a binomial here, the square root of 2x plus 1 plus the square root of 2x plus 2h plus 1. That is about as nasty a denominator as I think I have seen, but I want to remind you guys to keep your eye on the ball. The only thing that was the problem in the denominator was this h. So let's see if we can get it to go away, and I think we can. Now again, we're distributing this negative here, and that does some nice things for us. 2x cancels with what is actually a negative 2x. This 1 cancels with this negative 1 here. And so my numerator, when I distribute this negative here, is just going to give us, let me just cross it out, a negative 2h. That's all that's left in the numerator. And now because we're down to a monomial, we can cancel out this factor of h with this factor of h here. So even though that denominator is still really, really ugly, I'm pretty sure that we can go ahead and evaluate this limit now and let h actually become 0. Let's see how we might do that, everybody. Pretty sure this is going to work out. So our numerator is just a nice fixed -2 now, and the denominator, okay, that, when h is 0, is unaffected. Square root of 2x plus 1. When h is 0, that term right there, the 2h, drops out, and that leaves us with the square root of 2x plus 1. Okay, and then in parentheses now, we have a square root of 2x plus 1 plus a square root of, and again, that 2h term cancels out, 2x plus 1 as well. Okay, so what's that going to do for us, guys? -2 up on top, and actually something kind of cool happens right here, I think. This times this is a square root times itself. The square roots cancel, and you just end up with the binomial quantity 2x plus 1. That wasn't bad. And then in the second one, you're adding the square root of 2x plus 1 plus itself. So that is going to get you here a 2 times the square root of 2x plus 1. So not as bad as it could have been. And since that 2 in the denominator is a factor, it's being multiplied by everything, this 2 can cancel out with that 2 and leave you with a -1 over, interesting. We've got a 2x plus 1 times the square root of 2x plus 1. And if you were so inclined, I'm not sure this is any easier, that is actually 2x plus 1 to the 3/2 power. This first one was 2x plus 1 to the first. The square root puts it to the 1/2, and if you add those exponents together, you end up with 3/2. But honestly, I think it's probably easier to understand the way it was written before. So that is our general derivative, guys, f prime of x. And if I go back to the original problem, we're trying to evaluate this derivative and find the equation of the tangent line at a is equal to 4. So that's not what I wanted to have happen. Okay, so for a equals 4, let me switch colors. We'll go to purple here, and let's find f prime of 4. Well, -1 on top. And then here we go. 2 times 4 is 8 plus 1 is 9. And then it would be the square root of the exact same thing. 2 times 4 plus 1 is 9. And that cleans up a little bit. That's going to be a -1 over 9 times 3 is going to get us 27. That's kind of an ugly number right there, but that is f prime of 4. The next thing we need is the point of tangency, which comes from the original function. That would be f of 4. And if I remember this right, the original function was 1 over the square root of 2x plus 1. So that will be 1 over the square root of, and 2 times 4 plus 1 is 9. That gets us 1/3. So our point of tangency is going to be 4, 1/3. So what do we know here, guys? The derivative gives us the slope of the tangent. The original function is the point of tangency. So now we are going to go to point slope form with those two pieces of info. Y minus the y coordinate, 1/3, equals your slope, -1/27 times x minus the x coordinate of 4. So there's our answer in point slope form, but we probably want it in slope intercept. Y minus 1/3 equals -1/27 x. That'll be a plus 4 over 27. And then we're going to add a 1/3 on each side. And here, instead of writing 1/3, I'm going to write it with the common denominator I need of 27. 1/3 is 9/27. So it might look at first glance like I'm adding two different numbers, one on the left and one on the right. No. They both have a value of 1/3. So here we go. This should be our final answer. Y equals -1/27 x plus 4 plus 9 is going to be 13/27. And that would be our answer there for the equation of this tangent line written in slope-intercept form.